our next section, 4.4. This is the last section of chapter 4, is counting. So we want to count is how many ways things can happen. And let's look at the first one, factorial. You might see this in your calculator. Factorial is mean you multiply a number from that number down to 1, right? For example, 4 factorial is equal to 4 times 3 times 2 times 1. If you multiply it out, is equal to 24. If you use the calculator, you should have a factorial look like this on your calculator. And if you punch 4 and punch in that 4 in factorial, it should give you 24. I would recommend that you try it on your calculator. Different calculator is different, and if you don't have it, it's okay, you can multiply it out. You can make appointment one-on-one with the tutor, and I'm sure she can help you, or email me. I can probably Zoom and help you if you still need help with the calculator. But we all have different calculator, and I can't really go over during the lecture today. The special one is the 0 factorial. 0 factorial is equal to 1. Alright, so we want to see when we're going to use n factorial. So you use this one, when you want to arrange all n different items, you have n different items without replacement. So you pick one and you don't pick it again. Order matter or order count. So let's look at our example. How many ways can we arrange 7 different books on the shelf? So you have 7 books and you want to put on the shelf. So many ways you can put it. So we're going to use this one. Let me explain how do you use this one. So you're going to put the first one on the shelf. Since you have 7 books, there are different books, 7 books. So there are 7 ways you can put the first one on the shelf, the first slot. After you put the first one, because we don't, without replacement, you don't pick that one again. You're gonna put the rest into the second shelf, second slot on the shelf. So you will have 6 left. And then you're gonna put the third one on the shelf. You will have 5 left, and then 4, and then 3, and then 2, and then at the end you will only have 1 left, which is the last one. And you can see this is 7 factorial, right? So 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. I don't have calculator, so whatever that number is. The second one is m times n. You're going to use m times n is the number of way that 2 events, you have 2 events, alright, can occur. Giving the first event can occur m ways, and the second event can occur n way. Let's look at example here. For a 2-character code, you're going to have a 2-character code. The first one is going to be letters, and then followed by digits. And with replacement, it means if you pick A, you can pick A again. Well, the first one will always be character, so you don't pick character for the second one. So that's probably doesn't matter. The first character has to be letter, so we have what? 26. So there are 26 possible ways you can put in there. After the first character, you're going to put digits. So digits is going to be from 0 to 9, which is 10. So 10, so is 260 ways, different way. So that's basically m times n, 26 times 10. Alright? The next one is permutation. Permutation, the notation is look like this. P, N, choose R. This is called permutation. Permutation, you use it when you have n item and you're gonna arrange R of them. R can be less than or equal to n. And the formula is n factorial divided by n minus r factorial, and order matter. Alright, order matter. So let's look at example here. I have P, 5, 2. This means you have 5 items, but you're only going to arrange 2 of them. And order matter. without replacement. So the formula is 5 factorial, 5 minus 2 quantity factorial. If you don't have calculator, you can expand it out. 5 factorial is just 5 times 4 times 3 times 2 times 1. On the denominator, 5 minus 2 is 3, which is 3 factorial, is 3 times 2 times 1. And then you can cancel the 3, 2, 1, top and bottom. Then you end up with 20. Or you can use the calculator. Now the second one is called combination. The formula is n factorial, n minus r factorial times r factorial. This one order doesn't matter. You don't care what order. We will see example later. But that's the difference between the two. One is order matter, one order doesn't matter. Now the way you calculate is n factorial, n minus r factorial, r factorial. The same way, all right? You simplify it out. That is a form in the calculator. Some calculator, it has p and r. So you just put in the number and then give you all the answer. Same as CNR. Again, you can make appointment one-to-one with tutor or email me and we can go over it and to Zoom or something if you need help. All right. So that is the permutation and combination. So let's look at the example. All right. Hi everyone. Let's finish our chapter 4. Counting again. I'm talking about permutation and combination. So let's look at the first example. Find the probability of getting 2 cards. Initial handing consists of the ace of club and ace of spade in any order. And the keyword here is any order. So you want 2 cards out of 52 and any order. So we're going to use combination because order doesn't matter. So that's the formula. N factorial, my n here is 52 and my r here is 2. So n factorial divided by 52 factorial divided by 52 minus 2 factorial times 2 factorial. So I did this by hand. 52 is 52 times 51 times 50 factorial. I stop at 50 because I have 50 factorial on the denominator. That way I can just reduce it. Remember, 50 and 50 factorial are not the same thing. So I reduce 50 factorial and reduce 50 factorial here, and I just use calculator to calculate is 1326. So this is total possible outcome, and the outcome of have these 2 cards is 1 out of that, so it's pretty small. It's 0.0754%. Let's look at the next one. With a short time remaining in a day, a FedEx driver have time to make delivery at 3 locations among 8 locations remaining. Order count. So it's better if you're going to go to Palmdale first or Lancaster first. So order matter because they order count. So how many different routes are possible? So we have 8, but we only can do 3. And order count, so we're going to use permutation. So it's n factorial, which is 8, 8 minus 3, which is 5, and then you can use calculator, is 336 different way. The next one is you have n item and you want to select them without replacement, but there are some identical. Alright, so you're going to use this formula and order count. For example, how many different ways that the letter Mississippi can be arranged? And we don't care the meaning of it, we just want to arrange it. So we have 11 of them all together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But some of them are identical. M, I have 1 of them. I have 4 of them. S, I have 4 of them, and P, I have 2 of them. So I'm going to use this formula. So it's going to be 11 factorial divided by 1 factorial, 4 factorial, 4 factorial, and 2 factorial. If you calculate this, it's going to be 34,650. Alright, we finished chapter 4. Have a nice day or weekend. Bye.